First example that I'd like to look at where we're going to rationalise the denominator is this one here, the square root of 3 divided by 4 root 2. Now, when I talk about rationalising the denominator, what exactly do I mean? Well, what we mean, okay, is that the denominator, that means the bottom of the fraction, okay, needs to be rationalised. Well, we know that a rational number is one that can be expressed as a fraction. At the moment we've got a surd, so it's irrational on the denominator. We basically want to get rid of the surd. So rationalising means get rid of surds. In this case it means get rid of surds. And denominator means the bottom of the fraction. So with this expression here, we want to rewrite it in another form where we don't have this surd hanging out on the bottom here. Now, I've chosen this question deliberately because the bottom of this fraction is exactly like the example we had before. There was a 4 root 2, and we saw that when we multiplied by the square root of 2, our answer was a rational number. So when we look at this problem, we can think it'd be really nice if I was able to just put a square root of 2 on the bottom here, or multiply by the square root of 2. Because if I could do that, square root of 2 times square root of 2 would be 2, and I'd get that 8 on the bottom. I'd have a rationalised denominator. Unfortunately, though, I can't just stick a square root of 2 on the bottom of a fraction because I feel like it. But what I can do is I can choose to do something that I'm allowed to do that will end up leaving me with a square root of 2 on the bottom. And the clever thing that we're going to do is we're actually going to multiply by the square root of 2 divided by the square root of 2. Now there's two things going on here. First of all, why am I allowed to just multiply by this thing? Well, the reason we can multiply by that thing is it's actually just equal to 1. If I take anything, for example, if I take 2 for an example and divide it by 2, that's equal to 1. If I take 3 and divide it by 3, it's equal to 1. If I take pi divided by pi, it's going to be equal to 1. Similarly, if I take square root of 2 divided by square root of 2, that's going to be 1. And we know that if you just multiply by 1, it doesn't change any expressions. Things are always the same when we multiply them by 1. So that's why I'm allowed to just stick this square root of 2 on square root of 2 here. The second thing that's going on, and the second reason I'm doing this, is that if we know how to multiply fractions, if we remember this, we'll remember that the rule is you multiply along the numerator, so we're going to do square root of 3 times square root of 2, and you multiply along the denominator. And we know that if we were to multiply along the denominator like this, from our previous question, the result is going to be rational. So let's work this out. Square root of 3 times the square root of 2 is what's going to go on the top of the fraction. On the bottom of the fraction, I'm going to get 4 times the square root of 2 times the square root of 2. I'm not going to go through the detailed working out here again, because we did that on the last problem. But the result to this, the bottom of the fraction, of course, is going to be 8. And on the top, which I've probably done my fraction sign a little big, on the top, I'm going to have square root of 3 times square root of 2, which is the square root of 6. So what I have here, okay, is another way of writing the first problem. They're the same number, and you could check that by sticking them in a calculator. You'd get the same decimal output from these two. They're equivalent. However, this one now has a rational denominator. That is, the denominator doesn't have these messy surds in them anymore.